Welcome back, girls. We will be continuing on with the C4 booklets today. This video will be quite short and to allow you to practice the questions yourself. So I'll give you some examples that we can work through together, and then later on you can complete the rest of the questions in your booklet, and the answers will be up on Show My Homework. So for right now, I want you to pause the video and complete the Do Now activity task in your booklets, which can be found on page 13. And once you have done so, click play and you can find the answers on the next slide. So here are the answers. For question 1, it's easy to remember. Mass is equal to Mr. Moles. Remember the animal. The mole, so Mr. Moles likes to dig, and that's the mass. Or you could do it otherwise. It could be moles equals mass divided by a relative formulas, which is just the MR. And in standard form, you remember you need to give your answer in standard form. It's not good enough if you just given it as a number with decimals. And let's move on. So we will be discussing ratios and how to balance equations. So we can apply the concept of ratios to balance equations. So in this equation, we've got 2 magnesiums reacting with 1 lots of oxygen, which makes 2 magnesium oxides compounds. So what we could say the ratio would be is a 2 to 1 to 2 ratio of reactants forming a 2 ratio of products. Okay, so let's work through this example together. It can be found in your booklets. I think it's directly underneath. Okay, so let's look at this equation that we've already looked at. We've got calcium and we've got oxygen. On the left-hand side, you should immediately notice is that something about the oxygens. There are 2 oxygens on the left-hand side, and there's only 1 oxygen on the right-hand side. So immediately what we should be coming to your head is that we need to balance. So what we do is we put a 2 in front of the calcium oxide. However, now that we've got 2 calcium oxides, no, it doesn't balance either because the left-hand side still has only 1 calcium. So let's put a 2 in front of the calcium. Now that looks balanced. We can fill in the table with the ratios. So we have got 2 lots of calcium, 1 lots of oxygen, and 2 lots of calcium oxides. So now look at part C. How many oxygens can react with 4 moles of calcium? Okay, so if we have 4 moles of calcium, let's put that in. How many oxygens react with 4 moles? Well, we can look at the ratio above. We've got 2 to 1. Therefore, 2 is half of 1. 1 is half of 2. Therefore, for 4 lots of calciums, we would need to halve the calciums for oxygens. Therefore, we would have 2 lots of oxygens. We would have 2 lots of oxygens. Don't worry about the calcium oxide, it's not asking you about the calcium oxide. Now let's look at question D. How many moles of calcium oxide would be produced from 3.5 moles of oxygen? Okay, let's say we've got 3.5 moles of oxygen. How can we get 3.5 moles to react with calcium to get calcium oxide? So what we can do is we've got 1 going to 3.5, so what we did is times 3.5. We can do the same on the end of calcium oxide, all we need to do is times it by 3.5. And what you should be getting is 7. Let's look at this worked example in your book as well. This one's a bit harder. So the question says, what is the maximum of iron chloride that can be made from 20 grams of iron? What we first need to do is we need to balance the equation. So we've got iron, Fe, reacting with chlorine to form iron chloride. So we've got 2 to 3 to 2. Next, what we need to do is we need to work out the number of moles that 20 grams of iron has, and we can do that using the formula that we've previously come across, which is mass is equal to Mr. Moles, Mr times moles. So the Mr of iron is 56, and if we divide and rearrange the equation, we should divide the mass by the Mr to find the moles, which is 0.357. Feel free at any point in this video to pause and replay if you are confused. So these are the moles of iron, which is over here. Then we need to work out the ratio of the reactants and products. So we've got 2 to 3 to 2. Then we need to calculate the number of moles of the product using the ratio. So the ratios of iron and iron chloride are equal. There's 2 to 2. That also means that their moles are equal to each other. So the moles of iron is 0.357, and the moles of iron chloride is also 0.357. Now we need to calculate the mass of your product, iron chloride. So the Mr, the molar mass of iron chloride, is 162.5. Now all we need to do is we need to multiply the molar mass by the moles. And what we should result in is 162.5 times 0.357 should give you 58 grams of iron. Now this all looks a bit complicated. So what we can do is we can use a table instead to make life easy. So this should give you exactly the same results, but it's easier to see and easier structured. So we've got the ratios as the first, so we've got 2 to 3 to 2. Then what you can always fill in is the Mr, you can always work this out. And then you are given some masses, and then you fill in whatever is blank. So let's try use this method. Let's look at calcium oxide. The formation of calcium oxide. Calcium reacts with oxygen to form calcium oxide. The balanced equation for the reaction is: calculate the mass of oxygen needed to make 30 grams of calcium oxide. So we've got this table in front of us. Let's fill in what we already know. So what we've got is the ratio. We've got 2 to 1 to 2. We know that the mass of calcium oxide is 30 grams. So let's put that in. Got 30 grams. What we can work out now is work out the molar mass of everything, so the relative formula mass of all the elements. So we've got calcium, which is 40. We've got oxygen. Remember, we've got 2 oxygens, so this becomes 32, not 16. So 16 plus 16 is 32. Then we've got calcium oxide. What we need to do is we need to add together 40 plus 16, and we should get 56. Now, what we can work out is the moles of calcium oxide. We've got 56 as the MR and we've got the mass. We can use the calculation of mass equals MR times moles. Sorry for the horrible handwriting. So we've got the MR and we've got the moles, so we've got the mass. So now we can work out the moles. We need to just rearrange the equation. So we need to divide mass divided by moles. So the moles should be 30 divided by 56, and you should get 0.53. Let me try clear this. You should get 0.53. 0.5 should have been okay. So now we've got the moles of calcium oxide. We need to calculate the mass of oxygen. So this is what we're interested in. Remember that we can work backwards, so we've got ratios to help guide us. We've got 2 lots of calcium oxide and 1 lot of oxygen. So what we can do is we can just halve the moles of calcium oxide to get the moles of oxygen, because we have a 2-to-1 ratio. So calcium oxide has 2 lots of calcium oxide and oxygen has 1 lot of oxygen. So we can divide 0.535 by 2 to get 0.267. So now that we have the moles of oxygen and we have the MR of oxygen, we can easily work out the mass of oxygen that is required. All we need to do is we need to times 32 times 0.267 to get X. Therefore, what you should see is that X is 8.5 grams. And there you have it. That's your answer. Always remember, girls, just fill in what you already know, put an X of what you're trying to work out, and always remember the key to working out anything in this table is the equation. So mass is Mr. Moles. Okay, let's go through this example, and this is the last example before I let you go off and complete the rest by yourself. So we've got aluminium reacts with chlorine to form aluminium chloride. The balanced equation for this reaction is, so we've got the balanced reaction. How much aluminium chloride can be made from 130 grams of aluminium? To spare us some time, I've filled in everything that we know, but I have left a question mark of what we are trying to work out. We are trying to work out how much aluminium chloride in grams, in the mass, can be made from 130 grams of aluminium. So we've got all the information in front of us. What we should already see is that we have all the information for this aluminium. All we have left is to work out the moles. Remember, the key is the equation. So we've got 130 and we've got the MR. So to work out the moles, we do mass divided by MR. So we've got 130 divided by 27. and that should give you 4.8. So let's fill that in. We are trying to work out the mass of aluminium chloride, but what we can immediately see is that aluminium and aluminium chloride both have the same ratios. We've got 2 to 3 to 2, so there's 2 to 2. Remember what I said? If the ratios are equal, the moles are also equal. So the moles for aluminium chloride is therefore 4.8. Now that we've got the moles, it is easy to work out the mass. So all we need to do is we need to multiply the MR times the moles to get the question mark. And what you should get is 642.13. If you are not quite sure how this is all worked out, pause the video and have a go yourself. Play around with the numbers. Just remember, your key is this equation. And girls, when you're attempting the questions, just always put down what you already know, and I advise you to use this table. It's easy to use, and just fill in everything that you know, what you need to work out, and anytime you have three things that are filled in, so for example aluminium has 3 things that are filled in, it's simple and easy to work out the missing pieces. So now that we've covered all of this, I want you to have a go at completing the rest of the questions in your booklet, and we will reveal the answers on Show My Homework. Other than that, girls, you're free to go and complete the rest of the videos, and good luck.